talk about exploring the normal probability distribution. We have three examples about curve. Lesson objective. Draw a normal curve. State the empirical rule finding the R of a curve. What is normal probability distribution? It's a continuous random variable. Many random variables are either normally distributed or at least approximately normally distributed. Example, height, weight, exam score. We have properties of a normal curve. The distribution curve is bell-shaped. The curve is symmetrical about its center. The mean, median, and mode coincide at the center. So, there are properties of a normal curve. The tails of the curve flatten out identically along the horizontal axis but never touch it. Under the curve is equal to 1 or 100%. Then we have a two-factor that the graph of the normal distribution may depend on. So, yan ko ano ni kay mean U, yes, standard deviation Q. Normal probability distribution. Large value of the standard deviation make the normal curve short and wide. Small value of the standard deviation yield a skinner and taller normal curve. So, mani ang example sa curve sa kaning babaon, mani example sa curve large, then kaning ubos may siyang small, lahi sila nga kuan pero but same sila nga curve pero lahi iyang kuan.
The empirical rule. The empirical rule is also referred to as the 68, 95, and 99.7% rule. What tells us for a normally distributed variable are true? The empirical rule is a quick way to understand how data is spread out in a very normal distribution. What the rule tells us? When a variable is normally distributed, the following three things are always true. The 68%, approximately 68% of the data lie within one standard deviation of the mean. The 68% called middle ground. Most of your data lies right here in the center. And the 95% is approximately 95% of the data lie within two standard deviation of the mean. The 95% called most people. Everyone in the group fit in this range. And lastly, the 99.7%, approximately 99.7% of the data lie within 3 standard deviation of the mean. This called nearly everyone. This covered basically every person in the data set except for an extreme outlier. Why is this useful? This rule helps you predict where most of your data will be. For example, if you know the average height of a group, you can use this rule to figure out how many people like to be very tall or very short.
Validating the empirical rule. The score of senior high school students in their statistic quarterly exam are normally distributed with a mean of 35 and standard deviation of 5. Question A. What percentage of score are between 30 and 40? Our given mean was 35 and our standard deviation was 5. Let's find the range in terms of steps. If our standard deviation was 5, let's add 5 to the right side and minus to the left side. The final answer is 68% because, you see, the negative 30 to positive 40 is 68%. The rule states that approximately 68% of data fall within one standard deviation of the mean. Question B. What scores fall within the 90% interval? The empirical rule states that 90% of data fall within 2 standard deviation. Calculate the interval into mean, positive, negative 2 standard deviation. Just like what we do in the question A. But this time, let's multiply by 2 our standard deviation since we are going to find the 95% interval. So that our final answer is 95 between 25 and 45. On this part, we have a table to help us to practice calculating the zone quickly. It doesn't matter how large or small the numbers are. The logic stays exactly the same. To find this interval, we use the formula mean plus negative k times standard deviation, where k is 1, 2, or 3. In example A, our mean is 20 and our standard deviation is 2. To find the 68 interval, we need to add and subtract 2 given as 18 to 22. For the 95% interval, we are going to standard deviation, which is 4 points, resulting 16 to 24. And the 99.7 interval, we go 3 standard deviation out, reaching 14 to 26. Now, let's look at example B, which uses decimals. Our mean is 87 and our standard deviation is 5.5, even with a triple number. One standard deviation gives us our 86.6 range of 81.5 to 92.5. Two standard deviation, which is 11 points, give us our 95% range of 76 to 98. And finally, standard deviation 16.5 points covers 99.7 of our data ranging from 70.5 all the way to 103.5. This table shows us that the bell curve is a universal tool for organizing and kind of.
The standard normal curve is the normal probability distribution. It has a mean equals to 0 and the standard deviation equals to 1. So the letter Z is used to represent a standard normal random variable. A z-score tells us how far value from the mean. It shows the distance in terms of standard deviation. The top graph shows a normal distribution with values like -3, -2, -1, and the mean has +1, +2, and +3. The bottom graph shows the standard normal distribution, where the mean is 0 and the values are shown is -3, -2, -1, 0, and +1, +2, and +3.
Formula written out on us is our sample data. The observed value is 67 inches, the mean is 66 inches, and the standard deviation is 2 inches. Step 1. Substitute these numbers into the z-score formula. Step 2. Compute the numerator. 67 minus 66 equals 1. Step 3. Divide by standard deviation. 1 divided by 2 equals 0.5, so the z-score is 0.5. Therefore, the z-score for a height of 67 inches is 0.5. That means 67 inches is half a standard deviation above the mean. A normal distribution with mean 66 and standard deviation 2 will mark the mean and the observed value 67 and show that this point is half at standard deviation to the right of the mean. A z-score of 0.5 tells us the observed value is half a standard deviation above average. This is a small positive deviation.
The tables of area under the normal curve is also known as a z-table. So later, pakilala ko ninyo sa ang forma sa z-table. Nash duha ka part ang z-table, it has negative and positive. So later, makita mo later. The z-score is a measure of relative standing. It is calculated by subtracting the mean from the measurement x and then dividing the result by the standard deviation. The final result, the z-score, represents the distance between a given measurement x and the mean, expressed in standard deviation. So, the result of the z-score is na-represent siya sa distansya sa normal curve. So, the x and the mean are expressed in standard deviation. So, this is what the z-tables look like. So, sa taas na siya negative and sa ubos na siya positive. Pero pwede na siya malahi, pwede siya kanang mabuwag. Kaya taas mo na siya sa nod, pataas yun na siya. Nakat na siya pirang apart. So, remember, kung may tag more than, ang atong paytaon na area is from start siya here until where ang atoang x or where is atong z. So kung more than arita mag-shade, and when you say ka ng less than arita, so opposite siya. When you say less than arita pikas, and kung between po, so sa tunga siya, sa tunga ta mag-shade, or sa tunga nga kung may tag-shade is kung ara ang area atong paytaon. Ang more than ug at least is the same ra na siya. Same as the less than and at most. This is also how you use the z-table using this solution. Since we're only using 2 decimals away, so we have to round it off. So that will be the answer, negative 1.22. So atong first button is, ito pa itaon ang negative 1.2. And then ang ikaduha nga decimal, which is the 2. And kung asa sila magsugat, is muna atong answer or the area that we are looking. So ina na siya kadali paggamit og z-table. So we have an example here. Scores in an exam are normally distributed with a mean of 65 and a standard deviation of 9. Find the percents of the scores that A less than 54, B at least 80, and C between 70 and 86. So let us start with letter A, less than 54. So P of X is less than 54. So to calculate it, we have to find the X, which is 54, and we will use the formula, then calculate. We have a 54 minus 65 divided by 9. So the answer will be negative 1.2222. However, we still have to round off pa, so it will become negative 1.22. Using the z-table, so we have to find negative 1.2 and the 2. Kung asa siya magsugat, muna siyang ato ang answer. So using the normal curve, so atong z will be negative 1.22, so there siya dapita since we're using the standard normal curve. So kana siya nga area, that will be 0.1112. So ano tong area nga ibaitagan niya sa atong z-table. So P of X less than 54 is equals to P of Z less than negative 1.22 is equals to 1112 or 11.12%. Let's go to letter B. At least 80% or P of X is at least 80%. Or P of X is more than 80. So same ra na sila. So our X's will be 80. So we have to calculate first using the formula. So Z is equals to 80 minus 65 divided by 9 is equals to 1.67. And to check on the Z table, we will find 0.9525. But that's the answer sa pika side because we are using at least. So ang ipitaman is ang they're apart. So we have to subtract it since remember the under the normal curve is equals to 1. So we have to subtract 1 to find the answer inside that shaded part. So 1 minus 0.9525 is equals to 0.0475. So muna siya ang area under that one or 4.75%. So let's go to letter C between 70 and 86. So we have to calculate first the X is equals to 70 first. So calculate 0.56. Next is our 86 atong X, which is 2.33. And if you will check the Z table sa 2.33, that will be 0.99901. So that's the area sa right side. And for 0.56, we have 0.7123. That will be the area the left side. But we are using between, so pagkataon na itong area is ang nasa tunga or sa shaded part, ang shaded part niya. So the thing we have to do is we have to subtract. Ato i-subtract ang duha ka area nga ito nakita ganiha. So 0.9901 minus 0.7123 is equals to 0.2778, and that's the area between